We want to write a linear equation. We've been dealing with two different types of forms. The most common form we use is slope-intercept form, y equals mx plus b. This form is useful because if we know the slope and a y-intercept, then we can write an equation. Another form we've been dealing with is point-slope form. And point-slope form is y minus y1 equals m times a quantity x minus x1. This is useful when you have a slope and a point. We can just fill in our x and y values in the slope and we have an equation. And then if we need to, we can solve this equation for y to put it in slope-intercept form, because slope-intercept form again allows us to graph fairly easily. We also have something called standard form, and standard form is written as this: ax plus by equals c. Now, these capital A, B, and C, those are real numbers. So when we talk about standard form, what we're saying is we have our x and our y on the left side of the equal sign, and not only are A, B, and C real numbers, most of the time they're integers. And I'll talk about what I mean by that in a second, but these are real numbers. They stand for they're like constants. Our x and y are just like we have in any other equation. So these are numbers that a lot of times we write as integers. So let me talk about what I mean. It says write negative 5x plus 11 equals 1/2 y in standard form with integer coefficients. When it asks you for integer coefficients, again, A, B, and C are real numbers, but sometimes it asks you for integer coefficients. Integers, remember, are all positive and negative whole numbers, including 0. So when you look at our equation here, negative 5 is an integer, 11 is an integer, 1/2 isn't. So if we're going to focus right now on the integer coefficients part, we need to change this to an integer. Well, the way you do that is you just multiply by whatever the denominator is. Now if there's multiple fractions, you multiply by the least common denominator. Let's do that and I'll show you what happens. If I choose to multiply this side by 2, and I'll write it as 2/1. I can do that as long as I do the same thing to the left side. Remember, whatever you do to one side of the equal sign, you must do the other. Now watch what happens. If we use our distributive property, 2 times a negative 5 is going to be a negative 10x plus 2 times 11 is 22. Now, over here, what's 1/2 of 2? Just 1y. So notice how when we multiply by the denominator, or again, if it's multiple fractions, the least common denominator, you get rid of the fraction. Now they have integer coefficients. So let's focus on this part. Standard form. Remember, in standard form, our x and y are on the left side of the equal sign and equal to a constant. So let's move our y to the left side of the equal sign. Negative 10x plus 22 minus y equals 0, because y minus y is 0. But now let's get rid of this 22. And again, guys, you could have done this in different order. You could have subtracted 22 first and then gotten rid of the y. The most important thing to remember is that we get the x and y on the left side of the equal sign and the constant on the right side. So this answer here, negative 10x minus y equals a negative 22, is sufficient. It's standard form with integer coefficients. I do want to show you one more thing though. There's a lot of negatives and minuses here. So if you want to, when everything is negative and minuses, you can multiply everything by a negative 1. What happens is if you go negative 1 times negative 10, you get a positive 10x. Over here, if you go negative 1 times a negative 1y, you get a positive y. And then negative 22 times negative 1 is a positive 22. This is just a little bit nicer to look at. There'd be nothing wrong with negative 10x minus y equals negative 22. This is just a little easier to deal with. Again, standard form and integer coefficients. Let's look at this example. It says write standard form of the equation of the line passing through the point negative 5, 1 and with a slope of 3/4. When you're given a point and a slope, think point-slope form. what we're going to do is we're going to use this form to write it in standard form, because point slope form allows us with a point and slope to fill things in pretty easily. Y minus 1 equals our slope of 3/4 times x minus a -5. Okay, rewriting this, y minus 1 equals 3/4. Leave a little room there, I'll show you why in a second, times x, keep, change, plus 5. Okay, so now we want to write this in standard form. And even though it doesn't tell me to, I'm going to rewrite it with integer coefficients. Okay, again, that's traditionally how you see it. So remember when I said with integer coefficients, what you do is you just multiply everything by the denominator. The only fraction we have is this 3/4, so I'm just going to multiply by 4 over 1. Notice this is all being multiplied here, so I don't need to multiply the x and the 5. It's already being multiplied by 4. And whatever you do to one side, do to the other. So this becomes 4y minus 4. And here my 4's cancel out, and I'm left with 3 times x plus 5. Now you could have distributed the 3/4 first, and then multiplied everything by 4, and you would have gotten the same answer. I like getting rid of the fraction first, though, because then we're not worrying about adding and finding common denominators or anything. Okay? So now, we've got integer coefficients. We just need to put it in standard form. Don't forget you do need to use the distributive property. So this becomes 4y minus 4 equals 3x plus 3 times 5 is 15. If we add 4 to both sides, again, there's a different orders that you can do this in. 4y equals 3x plus 19. And then let's get rid of our 3x on each side. Okay, and I'm going to come up here for some more room. And again, standard form, we have our x term, then our y term equals our c. So I'm going to rewrite this as negative 3x plus 4y equals 19. Standard form. Okay? So don't overthink this. Basically, we're just using algebra manipulation with our point slope form or our slope intercept form to put things in standard form. Be careful to remember to use the distributive property. And even though it doesn't say to use integer coefficients, a lot of times it's helpful because then we're no longer dealing with fractions. And that's traditionally how you usually see standard form with only integer coefficients.